evening, sinners and saints, and welcome to the Sin Hound radio show here at the beautiful Rent-A-Friend radio studios at our secret underground studio high above the city. I'm your friendly neighborhood Sin Hound. We're gonna get our nerd on. When we last left off, we were talking about science. Because that's what we do here. We talk science, we talk scripture, we talk philosophy, we talk about whatever I want to talk about. Because it's my show, babies. Sinners and saints, today we are going to sort of tie up some loose ends, address some things that we have not addressed in the past. What I have hopefully shown you in the past installments of the Sin Hound radio show here on Rent-A-Friend Radio is that evolution fails on its own merits. It is asking the impossible. It is asking you to add by subtracting. It is asking you to basically just ignore all the evidence. It is a cult. It is a religion, a false religion, which stands between the believer and the true God by putting up a false God. And we are tearing down those idols, my friends. And so let's get to it. For another time, we are nearing the end of Creation, Evolution, Chocolate Bars, and Worms. We got one more installment after this, but today we are just tying up the loose ends. I dig this song, man. I don't even want to make it stop. So, people will present other evidence for Darwinian evolution. And basically, I'm gonna show you how all of the evidence for Darwinian evolution first assumes evolution to be true. And so it is just always a case of evolution being used as evidence for evolution. That is the way it rolls, babies. I'm going to bring you a little closer. We're gonna get close, you and me, as we talk some science. First, in no particular order, let's talk about homologous features. Defined as a common feature shared by different animals because it was inherited from a common ancestor with that trait. So, for example, you find this in all of your major textbooks as evidence for evolution. You've got humans, dogs, birds, and whales, and they have these bones in the forelimb. Let me show this to you. In the forelimb of a bird or a mammal or a lizard, you got these two bones here called the radius and the ulna, which allow you to do this. Try it at home, it's fun! Whee! So here's the thing. How do you get the forelimb to do that? Because when you are swimming, or walking, or running, or flying, birds and bats, whales and dolphins, people and cats, all gotta do this. Or you don't have the locomotion you need. So how do you make that happen? Well, the way that it works is, we have this pair of bones in the forelimb. Oh, I'm moving the wrong one. That is called the radius and the ulna, and they allow the movement of the forelimb to rotate around that central axis point like this, because the muscles are wrapped sort of around and it twists them. So it's got the same basic function. Now, the commonality of these features is called homologous. They're called homologous features, but homologous features are not simply any features that are in common. It's not just because they are similar, but they are homologous features because it was inherited from a common ancestor with that trait, which means that the whale, the bird, the dog, and the human on the evolutionary view all have a great-great-great-great-grandparent that had this trait, that ancestor evolved these bones and passed that on to all of us. So it is a homologous trait not because it is similar, but because it came from that common ancestor with that trait. So, you might ask yourself, all right, well, is that evidence of evolution? Well, let me just right off the bat say no. What this is, certainly what it can validly be, is valid as any, I think more valid as an interpretation, but of course I am biased. I'm not going to pretend I'm not biased. But this is evidence of common design. That there is an engineering problem. We need the forelimb to be able to rotate. How do you solve that problem? Well, you have an elegant, functional solution that works in multiple different categories. It works for whales and birds and dogs. It works for walking and for swimming and for flying. It's the same engineering solution. a common engineering solution comes from a common engineer. So while the evolutionists are going to point to this and go, there it is, evidence of common ancestry, I would say no, this is clearly common design. That this shows that all of these creatures were made by the same brilliant engineer that found a good solution for an engineering problem and said, this works! This is the best solution! Let's use it! That's what makes sense to me. But if you have the faith in evolution, then you would say, oh, well, maybe they evolved it from common... Now, here's the thing. How do we know it is a homologous feature? Let's point out the problem there, my little cats and kittens. The problem with calling this homologous features is that it is circular reasoning. Man, There we go. Hold on, I gotta get me out of the way here. I need to get me out of the way so you can see the truth, my friends. This is circular reasoning. Homologous features is circular reasoning, one of many in the evolutionary story, because it goes like this. Evolutionists call this a homologous feature because they believe it came from a common ancestor with that feature. So this is presented as evidence that evolution is true. That homologous features prove evolution. But the problem is that you can't consider them to be homologous features until you not only accept evolution, but a particular evolutionary sequence. You have to have the evolutionary tree that links these characters together already established, and that is one of the beginning foundational thoughts. Then you look at these and say, oh, they are homologous because the common ancestor we know they had that feature. So it's not just a common feature, it's homologous, but it's only homologous if the ancestor had that feature. Well, how do you know the ancestor had that feature? You look at the evolutionary tree. Well, what evidence do we have for that? We have these homologous features. So the tree proves that these are homologous features. And then the homologous features prove that the tree is right. Well, how do you know the tree is right? Because we've got homologous features. Well, how do you know those are homologous features, not just a similar design? Because we know that the tree is right, and they evolved from a common ancestor. Well, how do you know they evolved from a common ancestor? Because they have these homologous traits. Well, how do you know they're homologous? Because the tree... It's circular reasoning. Now, let me give you a metaphor. Let me hit you with a metaphor to help clear up what I'm talking about. It's like this. This is what I'm calling Darwin CSI. Darwin CSI shows up at the scene of the crime, and they're like, hey, there's a footprint, and that proves that this cat is guilty. And you'll be like, why does that prove the cat is guilty? It's guilty because we know that this is his shoe print. He left his shoe prints at the scene of the crime. And you say, well, how do you know those are his shoe prints? Like, we know they're his shoe prints because he's guilty. So obviously he was leaving footprints at the scene of the crime because he's the guy committing the crime. Well, how do you know he was the guy committing the crime? Because he left shoe prints there. Look, shoe prints. But how do you know those are his shoe prints? Because he's guilty. How do you know he's guilty? Because we found his shoe prints at the scene of the crime. You see the circular reasoning, babies? I hope you do. I'm drinking a little Arnold Palmer while you think on it. Arnold Palmer apparently was a golfer who invented drinks in his spare time. So it's half lemonade and half iced tea. Refreshing. So homologous features is circular reasoning. It has to be, because it requires you to accept evolution first before you can say it's homologous, and then you use the homologous as evidence that evolution is true, so you can call things homologous. It's just a big loop. It's a big faith loop. That's all it is. Let's take a look at another example of what I'm talking about. And once again, I got to move me out of the way here. Oop, there we go, dolphins. You got to see the dolphins. So, dolphins and bats. Here's some very specific commonality between our friends, the dolphins and bats. First of all, they have the radius and ulna in the forelimb. They have those two bones that allow the forelimb to twist. We call it radius and ulna. We didn't discover that. We just decided, well, they're a similar feature. We'll call it the same thing. And that similar feature is called homologous because it is believed by the evolutionary establishment that the radius and ulna of this fish creature and this fuzzy bird, they are both inherited from an ancestor that had that feature. And we're told that it proves common ancestry, even though one is a flying mammal and the other is like a big fish. We are told that, well, they started off something very similar, like a fish with legs, and they diverged on their evolutionary path. This is divergent evolution. They became two very, very different things, but they kept those homologous features that they inherited from the original parent generation. How much of this is based on observation? None. Zero. Squat. But if you believe the tree, this is the story the tree is intending to tell. That the fish grew legs, and those legs developed that radius ulna kind of thing. So one of those early ancestors, whether it's a fish with legs or an amphibian or a lizard, somewhere down the tree, depending on who you ask, because there's a lot of variations. And the evolutionary tree differs depending on what homologous feature you're following, too. If you follow bones, you get one thing. If you follow particular proteins or blood structures or heart structures, there's a lot of different paths you can follow to make that artificial animation sequence, but it doesn't give you the same Darwinian tree of life. It depends on what feature you're following to link things together to say, oh, you have this in common with this, therefore you have a common ancestor that had that. It's a different tree. You wind up with a lot of different trees. So what was the common ancestor of the dolphin and the bat that had the radius and ulna? I don't know. It depends who you ask. So the point is they call this divergent evolution because even though hypothetically they had this same common ancestor with the radius and ulna, they diverged so that one went back into the ocean to swim with his radius and ulna, and one took to the skies to fly around and eat bugs. God bless them, I love bats. So that's called divergent evolution. And those similar features, the radius and ulna, are called homologous because we believe they inherited that from the same ancestor. However, the bat and the dolphin have very similar sonar/radar for hunting food. They send out the little high-pitched squeak. It bounces back. They can tell where it's coming from and figure out where their food is going so they can track it down. But this is not an example of a homologous feature because evolutionists don't believe that they both descended from a creature with that radar. They think that they started off with the same common ancestor, something with the radius and ulna. They diverged through divergent evolution. And somewhere along the line, after the fact, they then both developed that very similar sonar for hunting their food. So radius and ulna, homologous, proves the evolutionary tree. But the sonar radar is not homologous. Why isn't it homologous? Because when we look at the tree, their recent common ancestor doesn't have the radar. So it's not homologous. Which means in order to even define something as homologous, this is another example that you first check the evolutionary sequence decided on in the evolutionary tree of life. And then you look at the observable evidence, in this case, dolphin and bat. What's the foundation? What's the starting point? You start with the evolutionary tree. Then you look at the evidence. You compare it to the faith in the evolutionary tree, and that's what you have to do before you even decide if similar features are homologous or not. So, the radar not homologous because we don't, according to the tree, it is not inherited from their most recent common ancestor. So, it's just coincidence that these two things evolved this common radar. It's convergent evolution. They evolved this similar feature. They started by diverging into different evolutionary paths, one into a fish and one into a flying fuzzy bird. And this is convergent because they developed that same radar. Now they're evolving to be the same. They evolved to be different. They're evolving to be the same. It doesn't matter what kind of change happens. We're just going to label it evolution. 31 flavors of evolution. Things they have in common prove evolution. Things that make them different prove a different kind of evolution. No matter what happens, evolution! Darwinian evolution is when things change. This is why the definition gets watered down so much, because it doesn't matter what changes happen. It's just things are changing. Whatever change, that's different. Hey, they have something in common, must have evolved. They have things that are different, that must have evolved. No matter what happens, it's evolution. So my conclusion, evolution is not science. It is unfalsifiable. It's a cult. Now, I'm not saying that all evolutionists wear tinfoil hats. But maybe they should. That's my opinion. I'm just putting it out there as a possibility. I'm not an expert on fashion. Although maybe I should be. Moving along. Fossils. Millions of dead things. Buried in rock layers, laid down by water all over the world. Now, to make sure I get out of the way of what's coming, I know you don't get to look at me for a few minutes. I'll be back. In the meantime, let's talk fossils, because you will be told over and over that the fossils prove evolution, but you're not going to be told that by people who study fossils. Couple examples. The horseshoe crab, dated by evolutionists to be 500 million years old. My question here, and if you read ahead, you know this. If something can remain unchanged for 500 million years, why do we think anything is evolving? Why do we accept the idea that evolution is this slow, gradual, and perceptible change where all life changes over time? There's a molecular clock running in every DNA strand in the world where slow, gradual mutations are changing things gradually over time through the evolutionary mechanisms. And then Horseshoe Crab walks in. He's like, yeah, I didn't get the memo. I haven't changed since 500 million years ago. Here's what the fossils show. And here's just one of many examples. Stasis. Plants and animals not changing for long periods of time, even on the evolutionary timeline, which I reject. I don't accept the hundreds of millions of years or any of that. But even assuming all their dates, even if you accept the evolutionary dates for all these fossils, what it shows is stasis. Plants and animals not changing. So even if you water down definition of evolution, so it just means evolution is change over time. Look, things not changing over time. That's what the fossils show. But wait, there's more. Can you identify any of these fossils? Take a close look. What do they look like? If that sounds like me drinking an Arnold Palmer, it's because it is. That sounds like me mispronouncing Arnold Palmer, it's because it is. The first one there is a bat, then a turtle, and a lobster, some kind of fish. I'm sure that if you're a fisherman, you identified it right away. My fish always comes in stick form, and then like a fern of some kind. So these all the fossils are identifiable kinds. No fossils have been found where people are like, we have no idea what this thing is. There are fossils that are so fragmented, we find so little of it that we can't identify it right away. But when you find a whole skeleton like this, that's a lobster, it's a turtle, it's a bat. And the bat is a fully formed, capable of flying bat. We don't have any partial bats. We don't have any on its way to being able to fly bats. Bats are bats. Fossils show sudden appearance. Plant and animal kinds fully formed and not evolutionary transitions. When the bat shows up in the fossil record, the bat can fly. He's a flying bat. He's not one of the innumerable transitional forms that... I mean, you should see the cartoons that people have to come up with to figure out, all right, how did we get from like a tree-climbing squirrel to a bat? It's embarrassing. None of them would be able to survive. The turtle, when the turtle shows up in the fossil record, he's entirely turtle. There's not a partially shelled partial turtle. Turtles are turtles. So the fossil record shows two things. It shows sudden appearance, where in the first fossils, the farthest down we go, the oldest dated, evolutionary dated fossils are fully formed, whatever it is. Plant or animal, we don't have transitions. It's bat, it's turtle, it's lobster. And we have stasis, things not changing for long periods of time. But you don't have to take my word for it. Here, pictured on the cover of Newsweek, is Stephen Jay Gould, evolutionary biologist, the Carl Sagan before Carl Sagan stopped being Carl Sagan. And he says this in his book. I guess this is an article. He says very similar things in one of his books. I think it's The Panda's Thumb. But this is from The Episodic Nature of Evolutionary Change. The extreme rarity of transitional forms in the fossil record persists as the trade secret of paleontology. The evolutionary trees that adorn our textbooks have data only at the tips and nodes of their branches. The rest is inference, however reasonable, not the evidence of fossils. The history of most fossil species include two features particularly inconsistent with gradualism, by which he means the slow gradual evolution of whatever. 1. Stasis. Most species exhibit no directional change during their tenure on Earth. They appear in the fossil record looking very much the same when they disappear. Morphological change is usually limited and directionless. So turtles show up totally turtles, and whatever changes we see, they're still just turtles. It's not turning into something non-turtle, it's just turtle. And number 2, sudden appearance. In any local area, a species does not arise gradually by the steady transformation of its ancestors. It appears all at once and fully formed. When the bat shows up, the bat is a bat. And that's all there is to it. One more time, Steve. The evolutionary trees that adorn our textbooks have data only at the tips and nodes of their branches. The rest is inference, however reasonable, not the evidence of fossils. So what this true believer in evolution, evolutionary biologist Stephen Jay Gould, is saying is exactly what I was showing you in this illustration. What we actually observe and what we imagine, what evolution imagines to be there. Okay, what we observe, what he refers to as the tips and nodes of their branches. That's what we have in the fossils. That's what we have in the zoos and the pet shops of the world. That's what the observable data is those distinct, different trees. What evolution has to infer, and he refers to it as reasonable to infer, is all of these connections that connect those trees together. So the fossil record does no better than the zoo in providing any evidence for evolution. And this is an evolutionary biologist admitting this. So what do we observe? We observe the creation orchard, distinct created kinds. And what are the two features of the fossil record that he acknowledges here? It's stasis and sudden appearance. So in the beginning, God creates the heavens and the earth. He makes everything according to their kinds. He makes all of the dog kinds. That's one tree. He makes all of the duck kinds. That's another tree. There's a turtle kind. That's a different tree. And evolution goes, well, let's pretend that they're all connected. But that doesn't show up in the fossils. The fossils don't show it headed that way. Doesn't show it coming from there or going to there. This is it. Oh, what about dinosaurs? We're always told, hey, the evolution of dinosaurs is certainly known. Here's a fun fact. This chart, which came originally from the Field Museum in Chicago, originally didn't have any of these numbers on it. This was just the family tree of the common ancestor to all the different dinosaur kinds. So this is the museum chart showing the evolution of dinosaur kinds, and added on top of that with those green boxes are the number of fossils known to exist. This complete list and a description of it is from Carl Werner's book, Evolution, the Grand Experiment. I recommend you check it out. It's a beautiful book. Lots of pictures of fossils, a lot of documentation of the actual observable evidence. And as you can see here, we have the created dinosaur kinds. Now, how many fossils do we have? Well, we've got 229 of that, 413 more of that, almost 400 of those, more than 200 of those, almost 300 of those, 200,000 birds. And yet they tie all these together with these lines showing the evolutionary tree of all these common ancestors of not only dinosaurs, but birds too. They've got birds in there. You know what's missing? See all those zeros? All of those imagined species, however reasonable, where we have to pretend that they are connected through evolutionary ancestry, through common ancestors. Zero. Zero fossils for any of those. None. Not a one. Not a single one. All of it is imaginary and pretend. And look how many fossils we've got. We've got hundreds in all these different kinds. And we have evolutionists who are convinced enough that evolution is a fact that they draw this evolutionary tree and put it up in museums or put it into textbooks. But how many fossils are used to create this tree? Zero. But let's talk about fossils themselves. How fast can fossils form? How long did these jellyfish lay on the beach or the seafloor waiting to be buried so they can fossilize? Because the story you get, the uniformitarian assumptions of evolution are that something dies, and through slow gradual processes it's gradually buried, and eventually through slow gradual processes it is permineralized so that all of the original organic material is eventually replaced, so that all the bone is eventually replaced by minerals, so it's not actually a skeleton anymore. It is a rock in the shape of a skeleton. And that's what you're told. But then we find fossils like this. These things didn't wait to slowly, gradually get buried. They had to be buried rapidly and deep, because if it's not buried deep, then bacteria can get in and entirely dissolve them. In order for these things to be fossilized, then decomposition cannot be allowed to happen. And that doesn't happen with a sprinkling of sand or mud. It's got to be buried deep and hard and fast so that bacteria cannot survive in the place where the original organic matter was. How fast do fossils form? How long does it take? Well, these guys were all in the process of eating. They were in the process of swallowing their lunch when they were fossilized. Again, how long did we have for this to happen? How long, what kind of gradual process could result in these fossils? Well, very simply none. It had to happen very fast, very suddenly, and apparently between 11:30 and 12:30 when they were taking their lunch break, I'm assuming. What about these fossils? How long does it take a rock to form? How old is a fossil? When you look at fossils, you hear the word fossil. Your brain just associates fossil with millions of years. But that's a champion spark plug in conglomerate rock there. How long did that rock take to form? Because Champion has not been making spark plugs for millions of years. And yet, there is a rock with a Champion spark plug embedded in it. Found out in nature. And the hammer to the right That is found in what is called Jurassic rock. If you're familiar with Jurassic Park, then you know that dinosaurs existed during the Jurassic, although not necessarily the ones in Jurassic Park. It's a whole thing. The point is, dinosaurs, we are told, went extinct, died off entirely 65 million years before the first human walked the earth. And yet here in Dinosaur Age rock is a hammer and part of the handle. So did dinosaurs make tools? Or maybe, just maybe, maybe something's wrong with the dating. But where do those dates come from? How do we look at that rock and say, well, this is Cretaceous rock. This is from the dinosaur times. How do you date a rock? How do you determine that age? Well, it comes from the geologic column. I'm sure you remember a little bit of this from 5th grade science. Let's go over it again just to make sure that we're on the same page. Where do we find the geological column and how are those ages assigned? Well, let's start off with the ages. How do we know how old a rock is? Well, inside a particular layer of rock, you will find fossils. And the species that you find in a particular layer of rock are called index fossils, and they are used to determine how old the rock is. So this chart you can find in any textbook or on a lot of websites. So the Devonian there, the evolutionary story tells us that in the Devonian period, 400 million years ago, the first amphibians evolved, jaw fishes diversify. So you expect to find some of the very beginning of amphibians and some a variety of jawed fishes, some early jawed fishes that are perhaps cartilaginous, yada yada. And now, why do we need to look for index fossils? Instead of just because I used to think that you just go out in your backyard, you dig down, and the first layer of rock you come to is the Quaternary one at the top there. You dig down a couple more, you hit Cretaceous. You keep digging, you hit Triassic. Not the case. And the reason why is this. First of all, the layers are not always found in this order. Sometimes the older rock is on the top. Sometimes things are not in the evolutionary sequence top to bottom. Take a look at this picture here. Which layer is the top layer? Well, in this picture here, it's impossible to say because we know that the bottom layer on one part becomes the top layer at a different part. So if you only had the far left side of the picture, you would easily say, well, as you come down, there's that dark layer, and then the next most recent layer is the one underneath the dark layer. But if you follow the curve around, that one is in fact, the dark layer becomes even underneath that. So the dark layer at the top becomes the very bottom layer. So which is the oldest layer? You can't tell just by digging straight down. You can't tell just by what order they're found in nature. Take a look at this. Which layer is the oldest layer? Pick a layer. At one place, it's the bottom. The next place, it's the top. And then it becomes the bottom again. And it probably becomes the top again. So because rock layers can be found out of order, you can't merely say, well, because it's this far down or what have you. You can't say because one layer is on top of another that you necessarily even know which one is the older one. You have to go by the index fossils because they're not always found in the right order. Moreover than that, sometimes they're not found at all. So Grand Canyon, we are told, is one of the best representations of the geological column in the world. But the problem is, we have 215 million years that are just missing. So the great unconformity there, you can see there's just a huge chunk of time just missing. We go from 740 million years ago to 525 million years ago. What happened to 600 million years ago? Or 550 million years ago? Or 700? All of that's just gone. It's just not there. So the great unconformity is somewhere where there was, 215 million years of deposits just got all eroded away, disappeared. So sometimes the rock layers are just missing. So not only can you not take them in the order they're in, sometimes there are whole chunks that get skipped. The very top layer of the Grand Canyon there, the very top. So if you're standing at the edge of the Grand Canyon looking in from the rim, that's already, 270 million years old? You're not standing on new rock. You're standing on 200-something million-year-old rock. So you can't just take the geological column and say the top layer is this old, the layer underneath that is older, because sometimes they're in the wrong order, sometimes they're missing entirely. So that's why we use index fossils. Because rock layers can be out of order or missing, we use index fossils. So we find an index fossil. We find one of these early amphibians and we say, oh, okay, this early amphibian fossil, therefore this is Devonian, therefore it's 400 million years old. Simple enough? Now, the question should arise then, how do we know how old those index fossils are? In order to determine the age of an index fossil, you have to check the age of the rock layer it's found in. So a fossil found in 350 million year old rock is 350 million years old. So in the Devonian period there, you've got that beginning of the amphibians, the first amphibian fossil there. So that is close to 350 million years old. We know that Devonian rock is 350 million years old. So since we find that fossil in rock that is 350 million years old, we know that that fossil is 350 million years old. But how do we know how old the rock layer is? So when we say the rock layer is 350 million years old, well, how do we determine that? Well, we look for index fossils. Index fossils are used to determine how old the rock is. So a rock layer with a 350 million year old fossil like this early amphibian means that the rock layer is also 350 million years old. Simple enough. But how do we know how old the index fossil is? Well, we check the age of the rock layer that the index fossil is found in. A fossil found in 350 million year old rock is 350 million years old. But how do we know how old the rock layers are? We use the index fossils to determine the age of the rock, to determine the age of the index fossil, to determine the age of the rock, to determine the age of the index fossil. And yes, this is really how it works. We use this to determine the age of that, and we use this to determine the age of that. Circular reasoning. Remember when I brought that up before? Round and round it goes. It's still going around like a record, baby. But where do we find it? I mean, the geological column shows up in your textbooks and museums, and it's this clear, neat list of evolutionary time periods with index fossils and with ages. Where on Earth, clearly the Grand Canyon isn't, because at the Grand Canyon, you're already 200 million years ago at the top layer, and then in the bottom, you've got tens of millions, hundreds of millions of years just missing. So where on Earth do we actually find the entire geological column? All right, these rock layers representing those ages in this order. Where did science discover this? Where do we find these today? Well, there's two primary places where you can find the geological column: in textbooks and museum displays. The problem is that's pretty much it. Like I said, if you go out and dig in your backyard, the chances of you hitting quaternary is pretty slim. And the rock layer at the top might be older than the layers under it. They might be upside down, because that happens. Sometimes it's just, hey, it's an inversion. It happens. So it is literally the only place where you can find the entire geological column. There's a lot of places where little pieces of it here or there, and if you sort of shuffle it and all put it together, but how do you do that? The evolutionary sequence. It's the evolutionary sequence which determines where to put the fossils, because the fossils are not found in this order. The fossils are arranged in this order according to the evolutionary dogma, and the evolutionary dogma tells you how to arrange those fossils. Once you've arranged those fossils, you use that to tell you which rock layer is older, because, like we've already determined, the older ones are not always underneath. Sometimes they're at the top. So what are we doing? We are using evolutionary dogma to determine the age of things, and then saying, well, look, the fossils are found in the evolutionary sequence. No, they are arranged in the evolutionary sequence. If you dig straight down from any place on Earth, you're not guaranteed to find this sequence. 99% of the time, you won't. And sometimes they're not found in a rock layer. On either side of David Reeves here, there are trees, fossil trees growing straight up through many, many layers of strata. So we call this a polystrate fossil. Poly meaning many, straight being the strata, the layer of rock. So polystrate fossils can include trees, can include dinosaur eggs. I've seen worms digging through multiple layers, clams digging through multiple rock layers, which means what? Which means that the slow gradual accumulation of rock over thousands and thousands and thousands and millions of years cannot be true. Otherwise, you have this tree either growing up through solid rock, and again, do trees start growing 30 feet underground? Do you see trees where the majority of the tree is underground? No, the roots are underground. So these trees must have been growing up like a normal tree, but then where did all these rock layers come from? It must have been buried in mud flows, because otherwise you have a tree either living for millions of years while it gets slowly, gradually buried through the accumulation of rock layers, or it's growing up through solid rock, both of which are impossible. Polystrate fossils show us that the slow, gradual accumulation of whatever it is over millions of years, the old age assumption of fossils cannot work for what we observe in the fossil record. The fossils are not found in the order we're told that they should be according to evolution. The rock layers are not found in the order that we're told they should be according to evolution. And when we look at the actual fossils, we see things like this that say the time frame that we're told that these all came together, that it's supposed to be slow, gradual accumulation over millions of years, cannot be true because polystrate fossils would be impossible, but we find them all over the world. What does explain this? Well, if it's a giant mud flow that's burying a whole forest, I don't know, how about a huge flood? Bum, bum, bum. But what would we really expect if the flood of Genesis had really happened? If the entire earth got flooded, as the book of Genesis describes, what would we expect to find? Well, we would expect to find millions of dead things buried in rock layers laid down by water all over the world. And what is it geologists actually find, or paleontologists, when they go out and dig in the rocks? What do they find? Do they find millions of dead things buried in rock layers laid down by water all over the world? Ba-dum-bum. In summation, fossils fail Darwin, and they prove Genesis. So, that's about it for this time. Wasn't that fun, though? I mean, you got to admit, we got some science going on here. There's a lot more that can be said on all these topics, but I just want to give you sort of an introductory to all of this, because so many times people have no idea where it is that young Earth biblical creation gets our ideas of the science. We get our ideas of the science same place everyone else does. But what we don't have is the atheistic starting assumptions and the forced atheistic conclusions. The observable data is the same. And here's the thing, like I just showed you with those polystrate fossils, it's the biblical creation and flood account that makes the most sense of what we observe. The evolutionary model forces you to start with the belief in evolution, to arrange the observed data differently than we find it. You have to arrange the fossils not how they are found in nature, but how Darwin tells us they should have evolved. And then that's our starting point. We are using evolution as the beginning to then arrange the fossils into an evolutionary sequence so it looks like evolution tells us it should, and then we look at that fossil arrangement and go, there, evidence for evolution. Which means what? Which means evolution is evidence of evolution. Because without the beginning belief in evolution, you don't come to the ending conclusion that the evidence supports evolution. You have to first start off with the evolutionary faith, use it to interpret the data, to arrange the data, sometimes to even just outright change the data, and then you can say, well, look, it supports our model. Of course it does. It has to. You haven't left it a choice. That's all I've got today, cats and kittens, sinners and saints. I hope you enjoyed some look into the ancient, crusty past. Woo-ha! Ancient and crusty. Every time I'm at a job interview, they say, describe yourself to us. And I go, ancient and crusty. That's why I'm working here at Rent a Friend Radio. Next time, we're going to talk a little bit more about not just the evolutionary theory, but also how it impacts us personally. It's about you, it's about me. So until then, continue to tell the stories that bring life. Be excellent to each other, and party on, dudes!